Okay, this is our lesson on evaluating functions, lesson 2.2. You have these notes. You should complete these in your notes as we go along in this video. So the goal of this lesson and these examples is to teach you how to evaluate functions by replacing variables with given values and expressions, and overall you should understand how to evaluate functions. So really the key here is replace. You're going to replace a variable with a given value or expression in the parentheses. So we'll start out. We have to be given some sort of function rule. Remember, this is just another way to write y equals negative 3x plus 1. So what we're given in something like A is we're given an x value and we're plugging in that value of x to find y. So f of 3 tells us to take this rule and replace x with the quantity 3. And then we just need to do the math, simplify. So we end up with negative 9 plus 1. So f of 3 equals negative 8. Since this is another way to write y, we were given x, we were finding y. So if we had to, we could think of this as an ordered pair, 3, negative 8. So you can see we'll plug in numbers and expressions in order to evaluate these functions. So for example, we'll do this one, f of negative 4. That's telling us to take negative 3 times x plus 1. We replace the x with whatever's in here, which is negative 4. Notice I'm using parentheses when I do that replacement. So we end up with 12 plus 1, which is 13. Same idea if you're starting with an expression for that replacement. We take out the x that was there and replace it with that quantity in the parentheses. Notice we didn't leave the x there. We totally take it out and replace it. So we end up with 15x plus 1. So when we're evaluating a function at an expression, our answer is another expression. If we're evaluating it at a value, our answer is a value. Alright, you guys should pause and do D and E. Alright, so you check your answers for D, you should have negative 20, and for E, you should have the new expression, negative 3x squared, or the opposite of 3x squared plus 1. Alright, so let's go through this one. The idea is the same. We're using the same rule from the beginning for f of x, which is negative 3 times whatever x is plus 1. So we replace and then simplify. And we get the new expression, 6x squared plus 1. Alright, so we had to review expanding binomials, because when you get to one like g, when we replace x with the quantity x plus 1, okay, we're going to have to distribute. And then combine like terms. H, we'll take out the x, replace it with 2x squared minus 9. It's a quantity, so that's why I'm using parentheses. And don't forget about that plus 1. Distribute. And then combine your like terms. Alright, you guys try I. Okay, so if you check your answer for I, see how you had to replace x with that whole quantity, which is a trinomial. So you had to distribute and combine like terms, and your answer is the new expression right here. So let's talk about J, because this is a little bit different. If you look at the way the problem is stated, notice you don't have x, you have the answer. So you're finding x, you're really given the function value, which is y. So remember, we had the rule y equals negative 3x plus 1. So we're trying to find x. We have what it equals, so this allows us to set up this equation, which we can then solve for x. Subtract 1, and we'd get x equals negative 3. And we could check that. We're saying that f of negative 3 should give us 10. So let's see, negative 3 times negative 3 plus 1 does equal 10. So it checks. All right, so in example 2, these are going to get a little more complicated because our original function rule was more complicated. Instead of having a linear function to start with, we're now starting with a quadratic function. So when we have one like this where we have more than one x term, replace each x with whatever you're asked to evaluate the function at. So in A, f of 3 would be 2 times 3 squared plus 3 times 3 minus 4. Everywhere there was an x in the original expression, you replace with it 3. And then we just simplify. And for this one, you're going to end up with 2 times 9, which is 18, plus 9, minus 4, right, which is 27 minus 4, so we'll get an answer of 23. All right, you guys try B. All right, check your answer for B, and you should get 16. All right, C. Now we're evaluating our function at another expression value, so same idea. We're going to replace every x with that new expression, negative 5x. Notice I'm using parentheses, which is especially important here in this first term because we have to square it. You need to realize that the negative, the 5, and the x are all getting squared. So you end up with 2 times the quantity 25x squared minus 15x minus 4. So we'll get 50x squared minus 15x minus 4. So when we're evaluating out an expression, our answer is still going to be another expression. In this case, a trinomial. I want you guys to try E. All right, so for E, we're replacing each x with a quantity x squared. Laws of exponents, that would become x to the 4th plus 3x squared minus 4, and the x to the 4th has a coefficient of 2. D and F are going to be part of your homework. So mark those right now, homework. And H we're going to do now, but G will be your homework. So let's look at H. So we're going to replace every x with a quantity 2x squared minus 9. So there's our first step, just rewriting that original function, replacing each x with that quantity 2x squared minus 9. Now it's a matter of doing the algebra. We need to follow order of operations, so we need to do the squared part first. So we'd end up with that squared would end up being 4x to the 4th. I'll do it up here. Remember, that's what squared means, times itself. So I multiply my first, my outers, inners, and last. So we'd end up with 4x to the 4th minus 36x squared plus 81. Here all we need to do in the next term is just distribute the 3, so we end up with plus 6x squared minus 27 and then minus 4. Now we still need to distribute this 2, so we have 8x to the 4th minus 72x squared plus 162. Let's rewrite the rest of this. Now we're going to combine all like terms. Let's see, here these are like terms, so we're going to combine those. We're going to get a negative. Let's see, 64? No, 66. X squared. Then we have 162 minus 27 and minus 4, which ends up being, I think that's, yeah, that is a 131. Okay, the last example we're going to do is J. And now notice we don't have something for x, we have what the function value will equal. So we set our original function equal to that expression. So now we have an equation that we have to solve for x. So to solve this for x, we should realize we have, let's see, 2x squareds on each side, so if we subtract those, we'd end up with 0. Now I'm going to add 4. So we end up with 3 equals 3x. So x equals 1. Okay, so you need to finish G, F, and D for homework. We'll practice these during our next class that we have together. All right, that's it.